Let's dive right into this explainer. Today, we are executing a purely technical breakdown of the architectural blueprint behind the Aurora AI framework. We are keeping things strictly focused on the system design and the mechanics, specifically detailing how Aurora processes data differently than standard probabilistic models. No marketing, just the architecture.
Here is the technical agenda. 1. Probabilistic versus semantic AI. 2. Transcenders and structural coherence. 3. The micro-model architecture. 4. Symbiotic nodes and training. And 5. Blockchain and coherence tokens.
All right, Section 1. Probabilistic versus semantic AI. We need to start at the foundational data layer to define exactly how tokens are processed.
Traditional statistical vectorization relies on multidimensional numeric vectors. It maps out millions of data points based purely on frequency and proximity in massive datasets. It's calculating statistical correlation, not actual comprehension. Aurora, on the other hand, utilizes semantic vectors. It applies targeted binary logic queries to rigorously define a word's structural meaning, its grammatical function, and its domain.
Think of this tokenization process mathematically, like an RGB color code. To define the color orange, a system doesn't need to reference millions of probabilistic data points. It just needs the exact structural values, red 255, green 100, blue 0. By isolating meaning through precise, defining queries, Aurora dramatically reduces vector size, which mathematically lowers the compute power required for processing.
Moving to Section 2, Transcenders and Structural Coherence. Let's move up the tech stack and look at the processing engine itself.
While traditional transformers generate output based on statistical likelihood via cross-attention mechanisms, Aurora takes a completely different route. It utilizes a mechanism called a transcender. The transcender replaces probabilistic calculation with structural wave coherence.
A transcender fundamentally shifts the compute workload. Instead of calculating massive statistical probabilities across billions of parameters just to force a match, the transcender checks for structural alignment. It ensures that the semantic vectors align logically and grammatically with a predefined coherence pattern. Mathematically speaking, this functions as wave resonance. The system essentially acts as a tuner. If a sentence is structurally coherent, its semantic vectors resonate in phase with an established master pattern. If it's incoherent, the transcender simply adjusts those vectors until the waveform aligns structurally. This entirely removes the need for brute force probability calculations, deeply optimizing the system's overall computational efficiency.
Section 3. The micro-model architecture. Now we'll evaluate the physical network design.
Standard architectures rely on monolithic, multi-billion parameter neural networks. As we know, those require massive amounts of energy and enormous data center infrastructure. Aurora instead deploys a distributed network of micro-models. Each of these micromodels operates in an isolated environment, and it's trained exclusively on one singular domain.
Here is the routing logic during a query. First, a lightweight classifier neural network analyzes the semantic vectors of the input text to generate a specific semantic signature. The system then uses that signature to dynamically route the query strictly to the required domain-specific micromodel, like astrophysics, for example. This completely bypasses the need to spin up a global database. The immediate technical output here is a drastic reduction in computational overhead. Because these micromodels are localized, they execute efficiently on standard consumer hardware, like mobile phones or laptops. This horizontally scalable architecture also allows for real-time, isolated model updates without necessitating the retraining of the entire system.
Let's examine Section 4. Symbiotic nodes and distributed training.
The infrastructure relies on distributed units, known as symbiotic nodes. A node is essentially a closed-loop environment, where a human operator and their dedicated AI agent collaboratively train a specific dataset. The human provides the precise domain expertise, and the AI agent structures the semantic vectors.
The lifecycle of a model follows a strictly defined pipeline. After local training at the node level, a micromodel must reach a mathematically defined structural coherence threshold. Once it hits that metric, it's deployed to the broader network. From there, the model's validity score is continually reinforced by successful peer usage.
But this decentralized topology introduces a major architectural challenge. How do you maintain structural integrity and prevent data degradation across thousands of independent nodes without a centralized server setting the rules?
That brings us to Section 5, Blockchain and Coherence Tokens. This operates as the network maintenance layer. Smart contract logic automates the network's governance. When a node successfully trains a model to that required structural coherence threshold, it is accepted. Subsequent peer utilization reinforces its validity, which then triggers an automated distribution of coherence tokens to the node operator. This provides an objective, cryptographic proof of computational utility.
By logging all of these contributions on a transparent, immutable blockchain registry, the system generates an automated, trustless feedback loop. Micromodels, referred to as intelligence cooperatives, can routinely audit each other without relying on a central moderator. Based on the distribution of those coherence tokens, the overarching system automatically redistributes compute resources, dynamically allocating priority and bandwidth to the most structurally sound and frequently utilized models.
It's also critical to note that the underlying code executing these decentralized autonomous feedback loops, the semantic vectors, transcenders, and routing algorithms, is strictly open source. It is licensed under the GPL, the General Public License. This guarantees the foundational architecture functions as a fully transparent, auditable infrastructure.
Ultimately, Aurora's blueprint presents a specific technical hypothesis for us to consider. If probabilistic guessing is replaced with structural semantic coherence, and monolithic models are effectively decentralized into blockchain-audited micromodels, are the days of the monolithic multi-billion-dollar AI data center computationally numbered. That concludes this architectural explainer.